Question number 32 is a 2 degree of freedom spring mass system undergoing free vibration with generalized coordinate x1 and x2 has natural frequencies given, okay, omega 1 and omega 2, and the corresponding mode shapes are given phi 1 and phi 2. If the system is disturbed with certain deflection and zero initial velocity, then which of the following statements are true? So option 1 is an initial reflection of x1 of 0 is equal to 6.32, x2 of 0 minus 3.16 centimeter would make the system oscillates only the second natural frequency. So if you analyze these questions, you know that an initial reflection of x1 0 is equal to 2 centimeter. x2 of 0 is equal to 3.16 minus 0.16 centimeter would make the system, and x2 of 0 equal to minus 6.32 centimeter would make the system oscillates with only the first natural frequency, because omega 1 is given to 33.9 radian per second and phi 1 is 1 minus 0.16. Okay, according to this we have more shapes like this. This is 1, this is minus 0.16, but for second phi is equal to 1, 0.16. we have more shapes like this. So it will not, this is the first, this is second, right? So it will not, it will not oscillate. So for that B is the right. And an initial condition of x1 of 0 is 2 centimeter and x2 of 0 minus 2 centimeter will make the system oscillate with a linear combination of first and second natural frequency. If you will see from here, the linear frequency of the second natural frequency. C is also the right, but A is not right and D is not right, would make the system oscillate with only the first natural frequency. So according to this we have B and C is the right option, but there are more explanation need to explain these questions, but I don't know how to solve these questions, but B and C is the right option. Next question is, a shock moving into a stationary gas can be transformed to a stationary shock by a change in reference frame. As shown in the figure, which of the following are true relating to flow properties in the two reference frames? Moving shock problem and stationary shock problem is given, and if we change, then we have D is the right option. T1 dash equal to T1, P2 is greater than P01, T01 is greater than T01, and P01 is greater than P01. Okay. So this is the properties if we change shock moving into a stationary one. So this is the condition, okay. This will change and this will constant. For a conventional fixed wing aircraft, which of the following statements are true? For 31, we have A, C, and D are the right option, okay. So these are the rules and conditions of conventional fixed wing aircrafts, okay. Next question is, which of the following statements are true? In this, for a given aircraft, stall speed increase with increase in altitude. Due to compressibility, as we know that the increasing the altitude, decreasing the density will be the right option. And see, everything else remaining the same. A tailwind increase the range of an aircraft. Yes, tailwind, tailwind is moving, the air is moving from the back side from right to left, okay, and aeroplane is flying this side, okay. So tailwind increase the takeoff length, landing distance, because it will help. It will help to move fast. So takeoff length will increase, landing distance, and reducing fuel consumptions, because it will help to move. Okay, tailwind, so it will reduce the fuel consumption. So range of an aircraft, obviously it will increase. For D, for a jet aircraft constrained to fly at constant altitude, there exists an altitude where its range is maximum. Yes, at high altitude, density is less dense, aircraft fly faster to obtain enough lift to maintain altitude, so range is maximum. B is also right. So B, C, D are the right option. 36. A conventional fixed-wing aircraft with a horizontal tail and vertical fin in a steady and level flight is subjected to a small perturbation. Which of the following statements are true? In this, we have vertical fin has a stabilizing effect on the lateral stability of the aircraft. A. And D. Horizontal tail has a stabilizing effect on the longitudinal steady stability of the aircraft. A and D are the right option. The ratio of the product of eigenvalues to the sum of the eigenvalues of the given matrix. So the ratio of product and the sum. So let's find out the product of eigenvalue. Is equal to determinant of A. So determinant of this matrix is 3 minus 3, plus 2, okay. And then minus 1, minus 2 plus 1, plus 2, 4 plus 3, we will get finally 8. And sum of this, so sum of the eigenvalues is equal to sum of the diagonal element, that is 3 minus 3 plus 1. This is the diagonal, we will get 1, and the product by sum. So product 8 and sum is 1. The ratio of product to the sum of the eigenvalues equal to 8. 8 is the right answer. Next question is, the different interval is given regularly using the 4 equal intervals by 2 methods. First, the trapezoidal rule and the Simpson rules. The absolute value of the difference between two calculations is, okay, let's find out. If x is given x square, x fx 1, if fx x value is 1, fx is 1, if 2, this is 4 according to this equation, 3, 9, 4, this is 16, if this is 5, and this is 25. So we just can 1 to 5 interval is given, so 1 to 5 we have fx data now. So according to trapezoidal rule, I is equal to delta h by 2 f1 plus 2 f2 plus f3 plus fn. This is the formula. So here we have f2 to f3. Fn is directly 5 because up to 5. Now what is delta h? So it is the two interval, that is 2 minus 1. Okay, so we'll say 2 minus 1 is 1, 1 by 2 divided by f1 is 1 plus 2, f2 is given 4, this value f3, f4, f5, 4 plus 9 plus 16 plus 25. Finally we will get 42. Okay, this is the trapezoidal rule. Next is Simpson rule. What is Simpson rule? Simpson 1/3 rule, right? Simpson 1/3 rule. So Simpson 1/3 rule is del h by 3 f1 plus 4 f2 plus f4 plus 2 odd number f3 plus f5. Del h is 1 by 3, f1 is 1 plus 4, f2 plus f4, right? So 4 plus 16 plus 2, f3 plus f5 is 9 plus 25. finally we solve, we will get 41.33. Now, trapezoid rule minus Simpson one-third rule is, we got from the trapezoidal rule, we got 42, this value, and here is 41.33. 42 minus 41.33 is equal to 0.66. So the answer is 0. Here 0.66. Okay. Next question is, the deflection y of a certain beam of limit L and uniform weight per unit length. The non-dimensional location x by L where the deflection of the beam is maximum. Actually, y is given W divided by 48 EI 2x to the power 4 minus 3L x cube plus LQ into x. Differentiation of this is, let's assume this one is C. Okay, C at x cube minus 9L x square plus LQ is equal to 0. Again differentiate, then C because it is constant, and 24x square minus 18 LX, which is less than 0. It should be less than 0 to find out the maximum value. Okay. Now we have equation, 8x cube minus 9LX square plus LQ is equal to 0. Okay. So if we solve this equation, okay, we will find x equal to 1, x is equal to minus 0.296L, and x is equal to 0.421L. Okay, if we solve this equation. Now, if we apply x is equal to 1 at in this equation, okay, maximum minima rules. So if it is negative, we will say maximum. Okay. So if we apply x equal to 1, so we will get y double dash is equal to greater than 0, that is minima. If we apply x is equal to, this is for x equal to L, x double dash greater than 0, if we apply x is equal to minus 0.296L, but y double dash less than 0, if we apply x is equal to 0.421L. What? Apply where? Apply in this equation. Okay. So if we apply x equal to this value, so we will get y double dash less than 0, which is maxima. Okay. And we have to find out maximum value. Okay. Where the deflection of the beam is maximum. So finally we got x is equal to 0.421L. Okay. Therefore, x by L is equal to 0.421 is the answer, because we have to find out what location x by L ratio. So this is the answer. X by L is equal to 0.421. Next question is, so a large water tank is fixed on car. Okay, if you will read this question, and the z of water is declared, so I have to find out this tension of this rope. So according to momentum conservation equation, summation of F is equal to d by dt rho vdv plus summation of mi vi mass flow rate, is the momentum equation, minus summation of mi vi of inlet. Okay. So till density of water to density is given, the tension in the countering group is, tension force is minus rho to square a naught plus rho v naught square a naught cos 60. So this is cos 60. If we resolve this one, so we will get here cos 60. Okay, 10 into cos 60, right? So after solving this one, we will get this one. value, finally you will get this. So finally we will have extension of this is equal to rho v naught square a naught into cos 60 minus 1. We take common from this equation. Density is given 1000. What is velocity? Constant velocity. Jet of the constant velocity is given 10 meter per second. Area is given. So area is given. No, here is also 5 centimeter. Here is also 5 centimeter. Okay, here is given T naught is equal to 5 centimeter. So pi by 4 and centimeter into meter. 0.05 square cos 60. Cos 60 value is 0.5 minus 1. Okay. Now, after we solving this, we get minus 98.17 Newton. So minus 98.17 Newton is the answer. Okay. So this is how it works, like this is what rho v square a, rho v a into v, mass flow rate into velocity, right? So mass flow rate into velocity, it is decreasing, water level is decreasing, and then that's why it is negative. And then rho v naught square a, mass flow rate into velocity, and it is resolved into cos 60, this value vertical, to find out the tension of this rope, right? So this equations construction by this figure, and finally we got the answer. Next question is a finite beam of elliptic plane form with aspect ratio is given, whose section is a symmetric airfoil. Angle of attack is given. Okay, so here aspect ratio is given 10, angle of attack is given 5. So I have to find out what induced drag coefficient, CDI, induced drag coefficient. We have lift coefficient is equal to 2 pi alpha. 2 pi angle is given 5 degrees. 5 degree will change to radians. So pi by 80 into radian. Okay. So we will get 0.548. It is elliptical. So E is equal to 1. So induced drag coefficient is equal to CL square divided by pi EAR, right? So 0.548 square divided by pi into 1 into 10. Finally, we will get 0.00956. This is the answer, 0.009. Next question is, consider a model of boundary layer with a flowing velocity profile. So, the shear factor defined as the ratio of the displacement thickness to the momentum thickness for this profile is. So here is already given shear factor and the ratio displacement thickness, momentum thickness. So first of all, I have to find out displacement thickness and momentum thickness, right? So displacement thickness delta star is equal to integration of 1 by delta 1 minus u by u, small u by capital U dy. Now 0 to delta 1 minus y by delta square. Here is given the condition y by delta square, right? For y is less than or equal to delta dy. If we integrate this, y of 0 to delta minus 1 by delta square, okay, yq by 3 yq by 3, 0 to delta, right? This is the limit. So delta star is equal to, this is delta minus 1 by delta square into delta q by 3 finally we will get 2 delta by 3. This is delta star. This is what? Displacement thickness. Now for momentum thickness, theta is equal to 0 to delta U by capital U 1 minus U by capital U into dy is equal to 0 to delta y by delta square 1 minus y by delta square dy, right? If we solve this equation, what will you find? Theta is equal to 0 to delta y square delta square dy minus 0 to delta y by delta 4 dy. You just multiply into 1 into y by delta, right? And now we have separated. Now we will integrate 1 by delta square y cube by 3 0 to delta minus 1 by delta to the power 4 y to the power 5 0 to delta, right? This. So after applying limit value, finally we will get theta is equal to 2 delta by 15. So shape factor, okay, shape factor is equal to displacement thickness by momentum thickness is equal to 2 delta by 3 into 15 by 2 delta is equal to 15 by 3. 15 by 3 is equal to 5. So 5 is the right answer. Next question is mass flow rate. Aircraft with a turbojet engine is flying at 270 meter per second. The enthalpy of the incoming air at intake is given, and how gas at the nozzle exit is given. The ratio of the mass flow rates of the fuel and air is equal to given. The chemical energy of the fuel, CV, heating value is given. The total loss of heat from the engine to the ambient is 25 kilojoule per kg of the air. The velocity of the object. Mass flow rate of fuel divided by mass flow rate of air is given 0.019. क्योंकि mass flow rate of air is equal to 1. Mass flow rate of gas is mass flow rate of air plus mass flow rate of fuel. So mass flow rate of air is 1 plus 0.019. Mass flow rate of fuel is given 0.019. So is equal to 1.019. So we got mass flow rate of gas finally 1.019, right? So from the steady flow energy equation, we have mass flow rate of air HA plus mass flow rate of air CA by 2 and 2, but there is given kilojoule, so we have to change kilojoule to. So this is the joule per kg formula. So we'll change this formula to kilojoule also. Okay. So we will apply 2000 mass flow rate of fuel into EF plus Q is equal to mass flow rate of the Hg plus Cg square by 2000 plus Eg. Now we have mass flow rate of air is 1. HA enthalpy value is given 260. The enthalpy of the air at intake 260 kJ per kg is 260 plus 1. CA is the velocity is given 270. This one 270 square divided by 2000 plus mass flow rate of fuel is given 0.019. Heating value or EF is given 44,500 because it is megajoule, so megajoule will convert to kilojoule per kg, so it will become 44,500 minus Q. Q is given then hit 25 is equal to, is equal to mass flow rate of gas is given 1.019, we just find out, and Hg is given 912 plus Cg square divided by 2000 plus 0. So now we got all, we have put in all values, only we have to find out Cg. Okay, Cg is housed velocity. After solving this, we will get Cg is equal to 605 meter per second. This is the answer. Okay. 605 meter per second. Next question is, hot gases are generated at temperature. The hot gases are explained, molecular mass, all values are given, the value of the universal gas constant given, the acceleration of gravity is given, the specific impulse of the rocket is. Specific impulse of the rocket we have to find out. First of all, we have to find out exit velocity, because the specific velocity formula is exit velocity divided by g. Okay, so first we have to know that v, exit velocity, is 2 gamma by gamma minus 1 into r divided by m. This is, r is equal to r naught by m naught. This is the formula, and so this is nothing but the r naught by m naught, t naught, 1 minus pc by p naught to the power gamma minus 1 by gamma. Yeah, this is the formula. Right? So gamma is given 1.32. R is given 8.314 to 10 to the power 3 divided by 22. 1 minus 0.1 divided by 14 to the power 1.32 minus 1 by 1.32, right? So this is the formula. Pc is 0.1 and Pa is the ambient pressure here, pressure of 14 megapascal rocket, and expanded ideally to the ambient pressure of 0.1. So Pc by P naught. P naught is the total pressure. So sorry, Pc and pressure is given here is just right here. Pc is 0.1 and P naught is 14. So after solving this, okay, we will get V is equal to 2118.96 meter per second, and just apply a specific impulse is equal to 2118.96 divided by 9.8 is equal to 216.2 second. Yeah. So this is the answer, 216.2 second. Yeah. This is the gravitational value. Next question is, this question is from the gas thermodynamics questions. Actually, bypass ratio is given. See, what is bypass ratio? Mass flow rate of cold by mass flow rate of hot gas is equal to 3. This is the bypass ratio. Okay. So, mass flow rate of cold plus mass flow rate of hot is given 100, right? Actually, this will turbofan engine is operated at sea level. And finally, the parameter fan pressure ratio is given, overall pressure ratio is given, bypass ratio is given. Assuming ideal fan and ideal expansion in the nozzle, the sea level static thrust from the cold nozzle is. So we just divide by mass flow rate of hot in all side. So this will become 3 because this is given by percentage 3 plus this is 100 divided by mass flow rate of H. So mass flow rate of hot is equal to 25 kg per second. So obviously it will become mass flow rate of cold is 75 kg per second. So the sum of this is equal to 100. Okay. So now exit velocity. Exit velocity formula is 2Cp T03 1 minus Pa by P03 gamma minus 1 by gamma. Okay. After solving this, okay, go back to the, okay, let's solve first these questions. 21005 into 329 39 1 minus 1 by 1.6 0.4 by 1.4. After solving this, we will get V is equal to 288.43 meter per second. So what is the thrust formula? Thrust is equal to mass flow rate into VE, that is mass flow rate of cold into VE 288.43 is equal to 21.63 kilonewton. The answer. So remember, this is actually the assuming ideal fan, ideal expansion of the sea level static thrust from the cold nozzle. From the cold nozzle, that's why we have applied cold mass flow rate. Here is also we have applied Pa by P03. So what is Pa by P03? So remember, this is the pressure ratio IF, that is P03 divided by P2 dash. So here is given fan pressure ratio is 1.6, that is 1.6. Okay, 1.6 is equal to P03. What is P2 dash? P2 dash is 1. Okay, 1 bar. Pa nothing but the P2 dash. Okay, so finally we will get from here P03. P03 dash is equal to 1.6 bar. Okay, that's why here we have applied P03 is equal to 1.6 and P is 1. So, and what about temperature T03? So T03, I am just writing here T03, that sorry, yeah, T03 dash is equal to T2 dash into pi of f to the power gamma minus 1 gamma. So T2 dash is given 288 Kelvin. Okay, sorry for this. T03 dash is equal to 288 and pi f is given 1.6, right? So 1.6 gamma value we will apply here, 1.4 minus 1 by 1.4, and finally we will get T03 is 329 329.39 Kelvin. So this is T03 dash. So T03 dash and P by P03 we just got from here, and we apply to find out exit velocity after then thrust. So finally we got 21.63 kilonewton answer. Go back to the previous question, that is question number 44. Here we have to find out 216.2 per second, right? But this is not the answer. I think answer might be we get 260. So after solving this, this value is different. Okay, we get this different value, and after a specific impulse, the procedure is same. After finding exit velocity, you have to change this value, whatever you will get after solving this, and you will get a specific impulse is around 260, and around this value 260 is the right answer. Okay, so okay, 44. solved. Now we will go to the 45 is already solved, and question number 46. In question number 46 we get, okay, according to this figure, let's extend this one. This value is WT2. From this to this value is CT2. This is C2. What is this? This is beta 2. Is 30 degree. Okay. And this one is beta 1. This one is alpha 1. Likewise, this one is alpha 2. And this is straight line. Okay. This is CA. So here beta 2 is given. C1 is given 140 meter per second. C2 is given 240 meter per second. W is given 240 meter per second. And W2 is given 140 meter per second. This is flow velocity, this is absolute velocity. So according to this triangle, you will get WT2, this value is equal to W2 sine beta 2. W2 is given 1, this triangle. W2 is given 140 divided by sine beta 2 is given 30 degree. Finally, we will get 70 meter per second. CA is equal to W2 cos beta 2 or is equal to C2 cos alpha 2. Okay, so cos alpha 2 is equal to W2 by C2 into cos beta 2, right? So we have all values like W2 140, C2 240, and cos beta 2 is cos 30 is 0.5052. So we got alpha 2 value. Alpha 2 is equal to cos inverse of 0.5052 is 5966 degree. Now we have to find out CT2 because WT2 we got, right? Once we find out CT2, so finally we will get U value. Okay, the summation of this we will get U value. This is the U. So how to find out CT2? CT2 is equal to C2 sine alpha 2. We can write because CT2 is equal to this value, this one, this triangle. If we talk about this triangle, right? This one. So C2 sine alpha 2 we just got. So now we will apply C2 is 240 given. Sine alpha is given 59.66. Finally we will get 207.12. So CT2 207.12 and WT2 70. So we just add 207.12 plus 70 is equal to 277.12. This is the answer. Okay, 277.12 meter per second. Next question is, a single stage axial turbine has a mean blade speed of 340 meter per second at design condition with blade angles at inlet and exit of the rotor being given. So let's solve. U is given 340 meter per second. Blade angle beta 2 is given 55 and beta 1 is given 21 degree. That is inlet, this is outlet, and area is given 0.08 meter square. Density is also given 0.9 kg per meter cube, and R is given, what is this degree of reaction? 0.4. So we have formula, R is equal to VF 2U 10 beta 2 minus 10 beta 1. 0.4 VF divided by 2 340 1050 minus 1021. Finally, we'll get VF value is 260.46 meter per second. That is mass flow rate is equal to rho ABF. Rho is 0.9, A is 0.08, and 260.46. That is 18.75 kg per second is the answer. Okay. Next question is, the airflow rate through the gas generator of a turboprop engine is 100 kg per second. So let's see, here T1 is given 600 Kelvin, T2 is given 1200 Kelvin, CPA is given 1 kilojoule per kg Kelvin, and CPC constant pressure, CPC a constant CPG is 1.2 kilojoule per kg Kelvin. So according to energy balance, you have mass flow rate A, CPA T1 plus efficiency CV into mass flow rate of fuel is equal to CPG mass flow rate of A plus mass flow rate of F into T2, right? Mass flow rate of A, mass flow rate of air is 100, Cp is given 1, T1 is given 600 plus efficiency is 0.9, Cp is 40 into 10 to the power 3 into mass flow rate of fuel is equal to Cpg is given 1.2, right? And 100 plus mass flow rate of fuel into 1200. What is 1200? T2. Okay. Temperature 2. Here is given burn gas are 1000 joule per kg Kelvin and 12,000 joule per Kelvin. Finally, there is unknown value is mass flow rate of fuel. Solving this equation, we will get mass flow rate of fuel is 2.43 kilojoule per second. This is the answer. Next question is, a rigid horizontal bar ABC with roller support at A is pinned to the columns B, B and C at points B and C. So these questions is difficult for me. So how to solve these questions? Let's try. This is A, B, C. Here is pressure, here is given A, okay, and you will see here reaction RB. Here is the reaction is RC, and here you will find the reaction is RAH. Sorry, it's vertical RAV. Here is RAH, right? R is value is 0, RAV value is 0. So this is pin, and there is one reaction here. So RB plus RC is equal to P, right? Summation of moment B is equal to 0, that is P into A is equal to RC into 100. We can write, because this value is 100, or RC is equal to PA by 100. We can write this is Question number 2. And you know, RB is equal to, from the equation number first, we'll put RC value. So P minus RC is PA by 100. P is common, so 1 minus A by 100. This is equation number 3. This is the RB formula. Finally, we got. Now, this is RB, right? Here is RB acting. Here is RC acting. And we know that this length. Okay. So, from BD, this is the BD. From the column equation, RB is equal to pi square E I nu divided by L square. You know, L1 effective length. This is effective length. So here you will see for one end is pin joint and other is fixed. So this is the circular, which means pin joint. So here you will see pin joint, right? This figure. And so for one end is pin joint, other is fixed. So we will find effective is equal to L by root 2. Okay. And if you will see in second one here, for both ends pin joint, so here you will see L2 effective is equal to L. So first of all, we have to find out RB. So RB is equal to what? Pi square EI divided by L effective. So 75, right? 75 square, and you know, one L by root 2. So this 2 will go up. Root 2 square is equal to 2, and RC is same, pi square EI, and L effective square is L, same as 125 square. Now we'll write here RB by RC. Okay, if we divide this formula and this equation, these two equations, so finally we will get 5.5. Okay, RB by RC is equal to 5.55. Now, from equation 3, you know, from equation 3 we have RB equal to P into 1 minus A by 100. And we have here, from here we have RB is equal to 5.5 RC, right? So just give this. How to solve this? We will solve like this, you know, P into 1 minus A by 100 from equation 3, and instead of RB we will put 5.55 RC. 5.55 RC, and RC is nothing but PA by 100, right? So we can write like this: P1 minus A by 100 is equal to 5.55 into PA by 100. Now we have P and P is cancelled, only A is unknown. So by using this we can find A value. A is 15.2 centimeter. This is the answer, 15.2 centimeter. Next question is, okay, just assume this is K1, K2. Okay, you know that T is equal to summation of 2AQ. 2 is equal to 2A1 E1 plus 2A2 E2. We can write 2 A1 is given 6 into 10 to the power 4 Q1. How? Plus 2. A2 is 9 into 10 to the power 4 Q2. Guys, A1 is this one, okay, 200 into 300. This one is 300. 300 into 200 is 6 into 10 to the power 4, right? Mm square. And this one is A2. So A2 is equal to 3 into 3, 9 into 10 to the 4. Okay, so that's why we can here like this. And torque T is given 12 kilonewton meter, right? 12 into 10 to the power 6 Newton mm. So I have changed to Newton mm because this area is mm, right? So Newton mm. So after solving this all equation, you will find 600 is equal to 6 Q1 plus 9 Q2. This is equation number first. We have equation beta is equal to theta by L is equal to 1 by 2 Ag Q into ds by T. Beta 1 is equal to 1 by 2 A1 G T. Okay, 1 by 2 A G T. T is also constant, we just take out, and ds is changing. QDS is changing, so 300. Just take from here, okay. So 300 Q1 plus 200 Q1, this value, and then this value, plus 300 into Q1 minus Q2, this value. So this value will go Q1 minus Q2. Again, plus 200, this value, 200 into Q1, right? So 1 by 2 A1 GT, this is 1000 Q1 minus 300 Q2. Now for beta 2 is 2 A1 GT 900 Q2 plus 300 Q2 minus Q1. How? This 300 Q2, this 300 Q2, this 300 Q2, 900 Q2, and this value is 300 Q2 minus Q1. Okay. Now we just equal beta 1 is equal to beta 2. We just equal this equation. Sorry. Okay. So once we just equal this equation and this equation, so what is unknown is there. So if we equate, so this all will be cancelled, right? No, 2A1. There is no place, so I will just rub this one. Okay, whatever. We just equate and we will apply A1 value and A2 value because G and T is constant, I think, for all. So we apply A1, G2 and then equate. Finally, we will get Q2 is equal to 1.09 Q1, this value. Okay. Now, from equation 1, this is just assume this is equation 1 and this one is equation 2. So from equation 1, we apply Q2 value and then finally Q2 is equal to, see, we have this relation and this relation, okay. So by using these two relations, we can find out Q1 and Q2 value. So finally, we got Q1 is equal to 37.95 and Q2 is equal to 41.366. Okay, these two value. Now we have to find out Q80. This one, Q80. So Q80 is what? Q2 minus Q1. So Q2 minus Q1 is equal to 0.42 Newton per mm. This is QAT. Now QAT is equal to tau into T. Okay. So 3.42 is the QAT just we got from here. Tau is given. Sorry, tau I have to find. Tau into thickness given 1.5. So by using this, tau is equal to how much? 2.28 megapascal. Finally, we get 2.28 Newton mm square or megapascal. Okay. Question number 51 is given. Area is 50 square. That is 2500 mm square. So, I is equal to b to the power 4 by 12 is equal to 0.05 to the power 4 divided by 12 is equal to 5.2 into 10 to the power minus 7 10 to the power 4. So if you see this equation, this is RA, this is RB. Okay, this is moment in A. So actually you have to find out compressive force experienced by the roller. Yes. So deflection at B due to UDL, uniform distribution load, is equal to deflection due to point load. Deflection at B due to UDL is equal to deflection due to point load, that is WL to the power 4 8 EI is equal to RB LQ divided by 3 AI. Okay. So we just apply the values, that is W is 20, L is 0.4 to the power 4, this value divided by 8 EI is equal to RB 0.4 LQ value and 3 into EI. Finally, we solve, we will get RB is equal to 3. So this might be the answer, RB is equal to 3. But in GATE Aerospace, we have got the answer is less than 3. I don't know how, but according to this, we applied this procedure and we got finally RB equal to 3. Let's check once again later. And let's try to solve yourself and then find out the answer if it is wrong. But according to me, the answer is RB equal to 3. Question number 42 is, here we have to find out the dimension D of the poles. This is very good questions actually. So this is D, that is we have to find out the thickness. But from this we can also find out the thickness, right? So area of signboard, right? Area of signboard is given right. Sigma y is 240 into 10 to the power 6 Newton meter square. Wind pressure is given 7.5 into 10 to the power 3 Newton meter square, right? Wind pressure is given, so wind force is 7.5 into 10 to the power 3 into 3 is 22500 Newton. How? Wind force is, F is equal to P into area. Now movement about ground. So here you will see the centroid is here, right? Centroid of the signboard. So from here to here, the length is 5.5 plus half. This is half, right? So we will get 6. So moment about ground is equal to f into distance d, that is 22500 into 6 meter, this one, finally 135000 Newton meter. Now m by I is equal to sigma y. This is the relation where I is equal to m y by sigma. M we got just 135000 into y. This is y. So y y is total d by 2, that is 250 by 2 into this is mm, so we change to meter, so 10 to the power 3 minus 3 meter, right? And sigma is given 240 into 10 to the power 6. So finally we will get I value. I is equal to 70.3. Oh, sorry. What is happening? Okay. Okay, so finally up to this we finally got I value, right? I is equal to 70.312 into 10 to the power minus 6. So as we know that I is I of this, right? So I of capital D to the power 4 by 12 minus a small d to the power 4 by 12. So capital D, this is capital D, by 2 is y. So this one is capital D. Okay. So 250 to the power 4 into 10 to the minus 12, we change to m meter 4 divided by 12 d to the power 4 by 12, right? And we have I value. I is 7312. So we have unknown d. From this we will get d is equal to 235 mm. This is the answer. Next question is, an airplane weighing 5500 kg is in steady level flight with a speed of 225 meter per second. So okay, this is CP. So take moment about CP. How bad? Moment about CP. W plus mv square by r. Okay. Into 20. This is equal to, sorry. Okay, it's equal to LT into 550. So guys, this one is LT. Okay. Here is, we see this about CG. Here is W, and here is also you will find mv square by r. That's why W plus mv square by r into distance 20. The distance is equal to LT. So I think it is moved like this, and LT into 1 by 4, it is moved like this, 550. So just equate. Finally W is given 5500 plus 9.81. Okay, weight, now it is weight in Newton plus mass is given 5500, V is 2225 square divided by 775 is 20 is equal to LT into 550, where LT is 15.03 kilonewton. This is the answer, 15.03 kilonewton. Next question is, a jet aircraft weighing 10,000 kg has an elliptic wing with a span of 10 meters. density of the maximum thrust. Okay, you have to find out maximum thrust. First of all, you have to find out aspect ratio. B square by S. B is given 10, S9 by S is given 30. 0.333. So you will see that area S is given 30 and S9 is given 10. Now, lift coefficient is 2W divided by SB square. True. W is given 1000, Rho is given 1.225 into 3 into 100 square. Right? Velocity is 100. Finally, we will get 0.5442. Now, drag coefficient is CD naught plus CL square by pi AR, right? CD naught is given 0.025 plus 0.5442 we just got, and pi is pi into 10. IAR is given 333. Finally, we will get 0.05328. This is what drag coefficient. Now, thrust formula is thrust is equal to W into CD by CL. W is given 100,000 into CD is 0.05328 divided by CL is 0.5442. We solve this, T is equal to 9790.5 Newton. This is the answer. Okay, 9790.5. Next and last question is, okay, so many data are given. Stability control. This is the most difficult topics. If you know the formula or basics, it is very easy. dCm by d alpha is equal to xcc minus xac. This is x divided by c into, okay, we will write here dCm divided by d alpha is equal to xcc minus xac divided by c into t. Okay, dc lwb by d alpha, lt st sc bar d clt d alpha t 1 minus de by d alpha. Okay, d alpha. Here you will see de by d alpha is given. See, E is given, E is equal to 0.4 alpha. So here we can write de by d alpha is equal to 0.4. Okay, so dc by d alpha is xcc is given 0.3 minus xs is given 0.25 divided by 1. Okay, dclwb is given wing body, this one 0.1 minus lt. Okay, remember this one is minus. Okay, lt is given, lt is 28, st is 80, s is given 350, c bar is given 9, multiplied by dclt by d alpha t is 0.068 into 1 minus d by d alpha 0.4. Everything is given. Only d by d alpha is confusion, so we just got it from this downwash. Okay, and after solving this, we will get minus 0.02401 per degree. This is the answer. Okay, so that's it for all questions.